Okay, 2022 deferred. Let's start with question 2a. Multiply out and simplify. Okay, couldn't be easier really. So we have squared, so we write it out twice and we multiply it out. So that gives us 4m squared plus 2m plus 2m plus 1 by 1 is 1. So we have 4m squared plus 4m plus 1. Job done. Any positive odd number can be written in the form 2k plus 1. So let's talk about why that is again. So the definition of even is it's divisible by 2. So in other words, you can divide into to the number without there being a remainder. So any letter with 2 in front of it means that it's even, because regardless of what k is, I mean, if k was 3, you'd have 2 by 3 is 6, even. If k was even, let's say k was 4, 2 by 4 is 8, so it's still even. And then if you have an even number plus 1, well, it's always odd. Why? Because even and odd numbers alternate. It's every second one. So anyway, they've given you the starting point. So it says any positive odd number can be written in the form this, where k is an element of z. So z means positive whole numbers, negative whole numbers, or 0. But it does say then that k has to be bigger than or equal to 0. So in other words, k is allowed to be 0, but it can't be negative. So that's just, I suppose, an extra stipulation. So this one is positive and negative whole numbers. And then this goes on to say that we have to narrow it down to just positive numbers, 0 or bigger. And any number in this form must be odd. Using your answer to part A, part 1, show that the square of any odd number is also an odd number. So 2k plus 1 is odd. Now, they want us to show that the square of any odd number, so in other words, if we were to square this, and it takes the same format as above, other than instead of an m, we have a k. So when we do that, I mean, we can kind of go straight to the answer here. So we're going to write 4k squared plus 4k plus 1. So it says, using your answer to A part 1, so we've kind of mimicked that, just replaced m with k, show that the square of any odd number is also an odd number. Now, if I have 4k squared, that is even. How do I know? Because it's divisible by 2, as in 2 goes into 4 without a remainder. I also know that this is even. Now, even plus even gives even. So think about this for a sec. If I have a 12 and a 14, I get 26, even. If I had 8 and we'll say 98, even. So even and even gives us even. So it's even plus 1. So therefore, it is odd. So using your answer to A1, show that the square of any odd number is also an odd. So we've shown it there because 4k squared is even, 4k is even for the same reason, divisible by 2. And we've remembered that even plus even is even. And then we just have the plus 1, which makes it odd. Part 3 we can't do because you're asked to prove by induction. I haven't taught you that yet. So we're going to skip just cross that out for the moment. We're going to skip part 3. We haven't covered it yet. Okay, so the next part is part B. Write the following expression as a single fraction in its simplest form where x is an element of or. So x can really be anything except a complex number. And we'll be covering complex numbers next year. So I need a common denominator because I have 2 fractions. So 3x minus 5 superglued onto x. The 2 already has the 3x minus 5 part, so it's just going to get the x minus 6. The 6 already has the x, so it's going to get the 3x minus 5. Now, just careful here, this is not in a bracket, so you only do the 6. So minus 6 by 3 is minus 18x. Minus 6 by minus 5 is plus 30 even. Underneath, we're going to leave that for now because we're not doing any sort of solving. Now, that gives us minus 16x plus 30 all over 3x minus 5 times x. Now, can we do any further simplifying? No, I don't think so. So that should be our answer there.